just in case whoever is watching the video didn't see the whole problem, they can always pause it. So, here you go. All right. Any questions on this one? All right. Pick a good one here. Oh, let's do writing. Okay. Okay, so let's say, for example, I want to solve x minus 4 over 3 squared plus 8 equals 89. All right, I'll give you a few minutes to start on this one. so let's get started on this one. Okay. So in this case, you want to get the x minus 4 over 3 squared by itself. Okay, so x minus 4 over 3 squared plus 8 equals 89. Just subtract 8 from both sides. Okay, so that gives us x minus 4 over 3 squared equals 81. Now that that's by itself, we can apply the property. Or just square root both sides. Okay, so we have the square root of x minus 4 over 3 squared equals plus or minus the square root of 81. Okay, the square and the square root cancel each other out. So that's x minus 4 over 3 equals plus or minus square root of 81. It's just 9. Okay, so we add 4 over 3 to both sides. These two disappear. So if x equals 4 over 3 plus or minus 9. Okay. So it usually helps to have common denominators to add them. So we know that 9, we can make that equal, let's say, I'll go through the steps. So 9 over 1, if we multiply that by 3 over 3, you get 27 over 3. Okay. So we can make this x equals 4 over 3 plus or minus 27 over 3. Okay. Which means if we separate them, x can equal 4 plus 27 over 3, or you can say 4 over 3 plus 27 over 3, if you didn't want to combine them. And x equals 4 over 3 minus 27 over 3. Okay. So if we add these two, x equals 31 over 3, which can't be simplified anymore, so that's good there. And for this one, 4 minus 27 is negative 23 over 3, which can be simplified also, so those are your two answers. All right, any questions on either one of those? Well, on that one? All right. Leave that up for a few more seconds. Okay. Okay, so before we start the next example, remember the perfect square trinomials. Okay. Here you have a plus b squared is equal to a squared plus 2ab. I don't know why I forgot the 2 there. Plus b squared. And a minus b squared is equal to a squared minus 2ab plus b squared. Okay. Now, some of the questions you will have to kind of revert back to this. Okay, so let's say, for example, if you wanted to solve using the square root property. And if you have x squared plus 10x plus 25 equals negative 18. Okay, so this middle term is positive. So since the middle term is positive, we're going to use this one. Okay, so x squared plus 10x plus 25 equals negative 18. You're going to notice, remember, for your perfect square trinomials, you want to look at the first and last terms. And you want to see if both of those are perfect squares. Where x squared, that can just be x squared. And 25, that could just be 5 squared. Okay, so in this case, your a is equal to x, and your b is equal to 5. That means if that middle term is equal to 2 times a times b, then it's just a perfect square trinomial. Okay, so we know that this has to equal 2 times a. Oh, let me put the times a times b. So that's 2 times x times 5. So it's 10x, so it's a perfect square trinomial. Okay, so we know for a perfect square trinomial, let me kind of make a little section there. We know that a squared plus 2ab plus b squared is equal to a plus b squared. Oh, straighten that up. So for this one, our a is equal to x and our b is equal to 5. So this is going to equal, where's I? X, I'm about to put b, x plus 5 squared. X squared plus 10x plus 25. Okay, so all we did was just convert our perfect trinomial on the left side to a squared binomial. Okay, so now we can just rewrite it. So, move that down a little bit. Okay, so now we have x plus 5 squared equals negative 18, which is a whole lot neater. Okay, so once again, we just square root both sides. Okay, so that means we have the square root of x plus 5 squared equals plus or minus the square root of negative 18. Oh, bring that up some. Okay, so for this one, the square and the square root cancels out. So you have x plus 5 equals plus or minus, and we might as well go ahead and simplify that now. Square root of negative 18 is just equal to square root of 18 I. And we know that 18 is 9 times 2. So that's equal to square root of 9 times square root of 2 times I. So this is just 3 square root of 2, and the I is on the outside. Okay, so we can just make this 3 square root of 2I. Okay. Then from there we just solve for x. So I'll put it right here. Okay, so if we subtract 5 from both sides, you have x equals -5. Remember, that plus or minus doesn't go anywhere just because you add or subtract from the other side. 3 square root of 2I. Or you can put 3I square root of 2. Either one would be okay. Okay. Or if you wanted to separate it, you can. So x can equal -5 plus 3 square root of 2I. Or x can equal -5 minus 3 square root of 2I. Like I said, it all depends on what exactly they ask for. All right, any questions on this one? All right. And let me make sure I got a good one here. Okay, so let's do, oh, one's still writing. Let's do one more example, then I'll give you one to start on. All right, so I'll do this one, and you can get the next one. Let's say if we wanted to solve 25x squared minus 60x plus 36 equals 18 using the square root property. Okay, so let me go ahead and rewrite it. Actually, for this one, let me word it a different way. So let's say you want to notice that remember your first and last term, those are the ones you want to look at. For your first term, 25x squared, you can actually just make that 5x squared. Same thing for 36. You can just make that 6 squared. Okay. So if we rewrite it, that gives us 5x squared minus 60x plus 6 squared equals 18. Okay, so that means in this case, if we're using, let me make a little side note here, a squared minus 2ab plus b squared equals a minus b squared. If we're looking for a perfect square trinomial, that means this would be your a, and this would be your b. We just have to make sure that this is equal to 2ab. Okay, so if this is equal to 2 times a times b, that means it has to equal 2 times 5x times 6. which it does. 2 times 5 is 10. 10x times 6 is 60x. So we're actually good there. So that means we can just plug in this A and this B into that formula. So we can see there that 25x squared minus 60x plus 36 is equal to 5x minus 6 squared. Okay. So whether or not you use the plus or minus all depends on that middle sign. If it's plus, then you use a plus b squared. If that's minus, you use a minus b squared. All right, straighten that out a little bit. Okay, so now we can just rewrite that whole thing. So we have 5x minus 6 squared equals 18. Okay, so now we can just square root both sides. So we have the square root of 5x minus 6 squared equals plus or minus the square root of 18. Okay, so the square and the square root cancels out, so that disappears. So we just have 5x minus 6 equals plus or minus. We'll go ahead and simplify that before we keep going. Okay, so we know 18 is 9 times 2. So square root of 18 is equal to square root of 9 times square root of 2. Square root of 9 is 3, so we have 3 square root of 2. Okay, so we have plus or minus 3 square root of 2. Okay, so now we just have to solve for x. Okay, so we add 6 to both sides, where the minus 6 and plus 6 cancel out. Okay, so that gives us 5x equals 6 plus or minus 3 square root of 2. Okay. Then we just divide both sides by 5. Anything divided by itself is just 1. So x can equal 6 plus or minus 3 square root of 2 over 5. Or you can make it 6 over 5 plus or minus square root of 3. 3 over square root of 2. Well, no, 3 times square root of 2 over 5. Either way. Or if you wanted to just stretch it out, x equals 6 plus 3 square root of 2. And like I said, if you wanted to, you could make them 2 separate fractions. You don't have to. Or x equals 6 over 5 minus 3 square root of 2 over 5. All right. So any questions on that one? Excuse me. All right, I'll leave that up for a few seconds. And I'll give you one to start on. if we wanted to solve 16x squared minus 32x plus 16 equals 4. Using the square root property. Remember, we're going to follow the steps from the previous example.